welcome to lecture 19. So, today we start with a new topic, Kepler's equation or Kepler's problem, which we are going to discuss. So, orbit determination we have already done. So, the basic problem, while you try to do the orbit determination, you have to propagate the orbit also. It appears as one of the requirement. Say right now you know the position and velocity vector of the satellite. So, what will be the position and velocity vector of the satellite in the future, or maybe it is a radius vector and the true anomaly. Okay. So, this problem it falls under this category. So, orbit determination is one problem, another one we have the orbit propagation. So, here basically we are going to deal with orbit propagation, but a simpler one. We have more sophisticated one, and which model in which we take into account the effects of all the planetary system, even the sun, and everything is included in that. Okay. And see, for that I am talking about the satellite, Earth satellite. So, effect of the sun and other planetary system, moon, all this will be included, and then it is propagated numerically. So, that is another issue which we will not discuss in this course, because it is not only beyond the scope, that much of time we do not have for this course. So, we will confine ourselves to the two body system, in which with respect to another body we are describing the system equation, and or the how the satellite or the planet will move with respect to the other one. So, in that context, how the true anomaly and it is a radius vector, or the radius vector and velocity vector it evolves with time. So, that is the topic for today. So, we have in the orbit problem, we can broadly divide into three categories. Determination of orbital elements, which we have already done, elements or orbital parameters, given r 0 v 0 at t 0. So, this is one of the problem, it is already done. Okay. So, the second problem is inverse of the above problem. So, inverse of the above problem that is given orbital parameters find r v at t. And the third problem, so this also we have already done. The third problem is given r 0 v 0 at t 0, find r v at t. So, this is the problem we are going to discuss in this lecture, okay. And this we typically call as the Kepler's problem. Okay. So, this is typically called, this is Kepler's problem. So, Kepler's problem especially it is described in context of r and theta, that you find the r and theta or the ephemeris, because many times you will see that you are interested only in the location of the satellite. So, where it is located in the sky, or in the because the Kepler dealt with planets. So, in that case where the planet or the moon all they are located. So, that refers to your theta. So, if the ephemeris we are especially talking about. So, in that case it is referring to r theta ephemeris. Okay, so, the Kepler's problem can be tackled using the following methods. So, here we have Kepler's problem, and this can be dealt using, say we are doing for the simple case. So, solving r double dot equal to minus mu by r cube r and numerically. So, this is one of the way. In the case you have more you are considering the effect of other planets. So, you will have the perturbation term which will be present here in this case. So, once we go to the 3 body problem. So, at that time we will take into account all those things. The second way is to find the orbital elements at time t 0 and propagate theta in time. Means this implies that get theta 0 and then find theta at t. So, in the future you are going to do this. So, this can be done, this part can be done both analytically and numerically. So, we are going to discuss this part, the analytical way of doing this, and once we do this. So, that particularly we call as the Kepler's equation. Okay, so, shortly we will write the Kepler's equation, we will derive it. So, Kepler's equation it appears as the m equal to E minus E sin E, where m this is called the true anomaly, this is called true anomaly, this one is called the eccentric anomaly, and as you know this E is eccentricity. Okay. So, for the steps to be carried out, it is very straightforward. Finding the future position of the satellite So, we start with, say we have the equation r square theta dot this equal to h for two body problem. It appears as a one body problem, only thing that the mu which appears, that mu gets modified as m 1 plus m 2 times g. Okay. Otherwise, it is similar to the one body problem we have taken right in the beginning. So, from this place we can write d theta by dt equal to h by r square, and from here we can see that dt will be equal to d theta r square divided by h, and integrate it from say t 0 to t, and here theta equal to theta 0 to theta. Okay. So, once we solve this problem, our job is done. So, for doing this we will utilize all the developments we have done earlier. So, say here in this case the left hand side we can write this as t minus t 0, and the right hand side, as we know, this is r equal to L by 1 plus e cos theta, this will be whole square, okay. And 1 by h, of course, this will come outside, theta equal to 0 to theta d theta. d theta divided by 1 plus e cos theta whole square. So, this is the basic equation for propagating theta. Now, we have multiple cases here. Once e equal to 0, you know this is simply circle, and it is a trivial problem. Because here in this case he gets, this term gets reduced to 0, we get 1, and it is simply integrating it, there is nothing much in that. Okay. The second case is, so this is the first case. The second case is of that of say the parabola equal to 1. In that case, t minus t 0, that gets reduced to L square divided by h d theta 1 plus cos theta whole square. Okay. Now, d theta by 1 plus 1 plus cos theta, because e equal to 1. So, we have directly written 1 plus cos theta. So, we can write here 2 cos theta divided by 2 whole square. So, here in the case of the parabola, this is also little simpler to work with, but once it goes to the ellipse, In that case, because of the presence of E, the whole thing gets complicated, and then we need to apply a special method to treat all these things. So, one step we will write more, and we will try to reduce this in terms of say L we will remove in terms of this L square by h is there. So, we will remove and make it in terms of h right now, or we can carry also. Let us forget about this, we will carry and later on we will treat it. Okay, so, t minus t 0 L square divided by 4 h. Okay. Now, sec square theta, we sec to the power 4 theta, we know we can write this as sec square theta by 2 times sec square theta by 2 d theta, theta equal to 0 to theta, and then in the next step we have L square by 4 h, theta equal to 0 to theta. This we write as 1 plus tan square theta by 2 times sec square theta by 2 d theta. Okay, and then we integrate this part by breaking it. One more step we will have to write. These are the standard technique of doing any problem. Okay, so, therefore, t minus t 0, the first term it can be written as, this is simply tan theta by 2, and the second term, now for that here theta by 2 is there. So, we have to take care of the 2 also. If it is only theta, then it is straightforward, but here 2 is there, and therefore, we account for that also. Okay. So, if we differentiate this, so we can see that this differentiation will be sec square theta by 2 times 1 by 2. So, that means, we have to put here a 2 to get to this sec square theta by 2 value. So, as we differentiate this, so 1 by 2 will appear, and this will be cancelled by this 2, and therefore, we get this quantity. And similarly, for this part, so we can see this is a result of tan to the power q theta by 2. Okay. So, once we differentiate this quantity, so this will appear as three tan square theta by 2. This is the first thing. Okay. We are differentiating first the tan to the power q theta by 2, and therefore, thereafter we differentiate for tan. So, that becomes sec square theta by 2, and then 1 by 2 especially it appears. So, this is the situation, and here it is a given only tan square theta by 2. So, that means that we should multiply here by 2 by 3 to eliminate all these terms, and finally, we put here theta equal to 0 to theta as the integration limit. So, this is the way we do this problem in the case theta 0 equal to 0, means you are measuring the position from the periapsis. So, in that case t minus t 0, that gets reduced to 2 tan theta by 2 plus here in this case also 2 by 3 tan to the power q theta by 2. So, this is only for the case where you have theta 0 equal to 0, otherwise it is not, otherwise we have to take into account for this factor also. Okay. Now, so therefore, and then we have this term also, here we are missing other term L square by 4 h, this is L square by 4 h. So, L square divided by 4 h, and we know that h square equal to mu times L. So, L then becomes h square divided by mu, and L square, this is h square by h to the power 4 by mu square, and this implies L square by h equal to h cube by mu square. So, we can insert there, and that becomes our final result. So, this quantity then gets reduced to h cube by 4 mu square times all these terms in the bracket, which is 2 tan theta by 2 and plus 2 by 3 10 to the power q theta by 2. So, this way we have been able to very simply solve this for the parabola. So, we will do it for the parabola, and then we will do it for the ellipse and also for hyperbola. Okay, case 2, case 3 already we have done for the circle, which was trivial, there is nothing to do in that, and then the other one we have done the parabola. Now, this is an ellipse. Ellipse is the case when E lies between 0 and 1, it lies between 0 and 1. So, in this case what will be the result? Okay. So, following the same procedure, we have written this as r square by h d theta square by h d theta Now, here in this case problem will be because of the presence of 1 plus e cos theta, r equal to L by 1 plus e cos theta. So, once you insert here in this place, so because of presence of this e, the integration gets complicated. Okay. So, for solving this problem, what we call the we change the variable, so that this gets into a simpler format. So, what do we do here, that say this is a circle, and inside this circle an ellipse is described, and somewhere the focus is located here. Okay. This part we call as the auxiliary or auxiliary circle, or we simply we can call as the circumscribing circle, which is bonding this ellipse. and then we have the radius vector here. So, if we extend this to this place, so this goes and touches the circle here in this place. Somewhere this point is your center, okay, and this point we call this as the focus. This is center and the focus. Here on this side we have the half of this is semi major axis, the quantity from here to here as per our conic section discussion, this is A e, and this quantity from here to here, this is A times 1 minus e, because that is the way we write R p equal to L by 1 plus e cos theta, and R for that the theta becomes equal to 0. So, this is 0 degree, and therefore, this is L by 1 plus e, and L is nothing but A times 1 minus e square. So, this divided by 1 plus e, this gets it to 1 minus e. So, here in this case we drop a perpendicular from this point to this point, and then extend this beyond this line to this place, and let us say that this point we call as the P and this point we call as M. This angle we show as theta, which is the true anomaly, and here the point on the bottom we call as the N. If we join the center of this ellipse and point P, then this angle which we show here, this is called E. So, E is called eccentric anomaly, and theta this we are calling as true anomaly. This is theta. So, what we have done that this point on the ellipse we have extended vertically, which cuts the circle here in this point at P. So, this radius of the circle will be A, because this length is A. From here to here this length is A, and therefore, this also becomes A. So this is touching the, this becomes the center of the circle and center of the ellipse also. Now, we use a property for the this auxiliary circle and the ellipse, which we write as P n divided by M n, this equal to P n A by B, A by B. This is the special property of this circumscribing circle. It bears this ratio, this point here, this point here, and this point here. Okay. So, this length and this length, they bear this ratio P n by M n equal to A by B. Okay. And this will help us solving this problem. So, P n will also be equal to A sin E, while the quantity, this is your R, that shown by the orange line. From this place to this place, this is R, the angle is theta here. Okay. So, M n this equal to R sin theta. Similarly, F n will be R cos theta. Okay, so using this these details, we will be able to work out, will be able to replace this theta in terms of E. We do not want to work with this theta, because once we are working with this theta, so E is appearing. So, our objective is to eliminate this E, and in that context we have in introduce another variable on calling this as the eccentric anomaly. So, the true anomaly and eccentric anomaly both are physical quantities, physical quantities. While earlier I have told you the mean anomaly is a purely mathematical quantity. We cannot show that in the picture, while the true anomaly and the eccentric anomaly we can show it like this one and this one. Okay. So, mean anomaly, this is purely mathematical quantity. Okay, so with this description, now we proceed further. So, already we have written on the previous page, we have written okay, the name we will change it, we will do little modification here. We will write this as P, and I have used this notation. So, I will write here as M. So, this is M, this is P and N. So, therefore, the ratio is the same, only thing the notation I am changing here, nothing else. So, M n by P n, this is equal to A by B. It is the same thing, only thing the symbols I have changed. So, therefore, I will change here in this place also. M n will be A sin E, M n is quantity from this place to this place, and P n will write as R sin theta, and rest other things are the same way. Okay, so, this way we have M n by P n, this equal to M n by P n, this equal to A by B. A by B. Now, we solve this. So, M n we have written as A sin E, therefore, A sin E, and P n we have written as R sin theta. So, this is R sin theta equal to A by B. So, A cancels out, and we get here R sin theta. On this side this goes, and this is B sin E. Similarly, what we can see here, this quantity is known to us from this place to this place. This is nothing but A cos E, and also this distance is known to us, which we have written as A E. Okay. So, F n, this quantity also this becomes equal to A cos E minus A E. So, F n, this is nothing but R cos theta theta, this will be equal to a cos E minus a cos E minus a times cos E minus E. So, what we can observe that this r sin theta and r cos theta, they are described in terms of this eccentric anomaly. Here also the eccentric anomaly is appearing. Okay, so, we have been able to eliminate, we will be able to describe r in terms of a, b and e, that is the semi major axis and semi minor axis. So, this we write as equation number 1 here, this is 2, 3, 4 and 5. This is 6, this is 7, and the next step thereafter, it is a logical step will be r sin square theta, this implies plus r square cos square theta, r square cos square theta, this equal to b square sin square E plus a square cos E minus E whole square, or this gives us r square. So, this is one way of writing it. So, we will continue for in the next lecture. Okay, little bit of the coordinates also we will write, because we have done already so much. So, I will write the coordinate. The coordinate of the point P. So, P which coordinate is x and y, directly we can write y equal to r sin theta, and therefore, from here this is nothing but b sin E, and similarly x equal to r cos theta, okay, r cos theta, and r cos theta we have written as a times cos E minus E. So, we do till this extent, and next time we will be working further with this. Okay. So, this will number as 7, 8, 9 and 10. This is coordinate of point P. Okay, so we end the lecture here, and next lecture will continue from this point only. Thank you very much.